Hey everyone, and welcome. Today we're diving into something that can trip up even seasoned Swift developers, that little @escaping keyword. We're going to demystify it, break it down, and by the end of this, you'll know exactly why it exists and when you need it. All right, let's get right into it.
So, if you've spent any time with Swift, I'm willing to bet you've run into that compiler error telling you a closure might escape. And you've probably thought, escape? What does that even mean? Well, you're not alone. And that's exactly what we're going to clear up today.
To really get why we sometimes need a closure to escape, we've got to start with what's the default? What are they escaping from in the first place? It all starts with Swift's built-in rule for closures.
Okay, so here's the deal. By default, Swift assumes any closure you pass to a function is non-escaping. And this is all about keeping your app safe and managing memory efficiently. It's like a promise from the function. Hey, I'm going to use this bit of code you gave me right now, and then I'm done with it before I finish my own work.
I love this analogy. Think of it like this. Imagine I walk over and hand you a Post-it note with a simple task written on it. Now here's the key. I'm not going anywhere. I'm just going to stand here and wait for you to do that task, and then you hand that note right back to me. The task is done, the note is returned, and we're all good.
And here's what that looks like in code. See this perform function? It takes a closure we're calling action. And look what it does. It just calls action immediately, right inside its own body. It's all done and dusted before perform even finishes. Super simple, super direct. No escaping necessary.
Okay, so that default behavior is nice and safe. But it creates a problem, a really common one. What happens when we don't want the code to run right now? What if we need that code to run later?
Right. I mean, think about a network call. You're fetching data from some API on the internet. That's not instant, right? It takes time. The function that starts that network call, it's going to finish its job in a flash, way before you ever get that data back. So you need your code, your completion handler, to just wait, to run after the data finally shows up.
And this is where Swift, being the safe language it is, steps in. If you try to make a closure wait like that without telling the compiler, it's going to stop you dead in your tracks with this famous error. It's basically the compiler waving a red flag and saying, whoa, hang on. This piece of code looks like it's trying to live longer than the function that got it, and you haven't given me the okay for that.
So how do we give it the okay? How do we tell the compiler, no, this is intentional, I know what I'm doing? Yep, you guessed it, that's where @escaping comes in. It's our way of explicitly telling Swift this closure needs to stick around.
So an escaping closure is, the total opposite of that default non-escaping one. It's a chunk of code that's meant to be executed after the function it was passed into has already finished and cleaned up. It's escaped from that original context. Let's revisit that Post-it analogy because it works perfectly here too. This time I hand you the Post-it, but instead of waiting, I say, hey, just do this whenever you get a chance. You take it, you stick it on your monitor, and I'm gone. I've left the building. That Post-it, our closure, is now living on its own, completely separate from me, just waiting for you to execute it later. See? It has escaped. All right, enough theory. Let's see where this actually shows up in the real world. You're going to see two main situations where you absolutely need escaping closures.
The number one place you'll see @escaping without a doubt is with asynchronous tasks. Basically, anytime you have code that needs to run later, think network calls, animations, timers, anything happening on a background thread. The code you want to run when it's done has to be in an escaping closure. So if we look at a classic fetch data function, you see it right there in the signature. We're marking that completion closure with @escaping. This is like our permission slip to the compiler, telling it this closure is going to live on.
And then, inside the function, look what happens. We kick off the work on a background queue using dispatch_queue.global.async. The fetch data function itself finishes instantly, but our little completion handler, it's now tucked away inside that async block, just waiting for the network call to finish. And this is the whole point, right here. By the time completion actually gets called with the data, the fetch data function is long gone. It's already returned and been wiped from memory. That closure absolutely had to survive. It had to escape its original function to be called later. Makes sense, right?
Okay, so the second big use case is when you need to store a closure somewhere to be used later on. I like to think of it as saving a to-do item in a list. You're not doing it right now, you're just saving the instructions for later.
A perfect example is a function like addHandler. It takes a closure, and its only job is to add that closure to an array of handlers. The add handler function finishes right away, but the closure itself is now sitting inside that array, living in memory, waiting for something else to come along and call it. It has definitely escaped.
Okay, so we've covered a lot. The why, the how. Let's pull it all together with a super simple checklist that you can use in your own code.
Let's just look at this side by side. It really makes it clear. Your non-escaping closure, that's the default. It runs right away, inside the function, perfect for simple synchronous stuff. And then you've got escaping. This is for later. The code runs after the function is gone, and it's absolutely essential for anything asynchronous or when you need to store that code.
So here's your mental checklist. It's really all you need. Next time you write a function with a closure parameter, just ask yourself, 1. Is this thing going to be executed after my function returns? 2. Is it part of an async operation? And 3. Am I storing it in a property or an array to be used later? If you answer yes to any of those, boom, you need add escaping. It's that straightforward.
But I do have to give you a quick word of warning. You know, with the power of escaping closures comes a little bit of responsibility. Because these closures stick around, they can accidentally create what's called a retain cycle if you're not careful with how you handle self inside them. Now, that's a whole other topic for another day, but it's something to be aware of. Look, at the end of the day, you simply cannot build a modern Swift app without using escaping closures. They are the absolute backbone of how we handle async patterns, completion handlers, event handling, you name it. Getting comfortable with them is a huge step forward as a Swift developer.
So, you've totally got the when and why of add escaping down now. But that little warning I mentioned about retain cycles, that brings us to the final thought I want to leave you with. You know when to use them, but what's that one big risk you have to manage? And more importantly, how do you do it? That's the next level of mastering closures, and it's a perfect topic to dive into next. Thanks so much for tuning in.